talking about Newton's 3 laws.
Giving you real-life examples of each one.
Let's begin.
Beginning with the first law. Any object at rest will stay at rest unless acted upon by an external force. Also, any object moving at a constant velocity will remain moving at that speed unless acted upon, of course, by an external force.
By pulling the flashcard quickly away from the cup, the dime will fall into the cup due to the force of gravity.
Our second example of Newton's first law will show Allie being propelled forward as the car comes to a sudden stop. The seatbelt will act as an external force and will stop her body from moving forward.
Okay, right now I do not have a seatbelt on, so that is no external force acting upon me. Okay, ready? Sudden stop. Now I will put a seatbelt on using as an external force. Okay, and stop. It stops me from propelling forward with the car.
Now we are ready to introduce Newton's second law. Newton's second law says, the acceleration of an object as produced by a net force is directly proportional to the magnitude of the net force, in the same direction as the net force, and inversely proportional to the mass of the object. That's a
Therefore,
mouthful.
the equation for this motion is F net equals mass times acceleration. And we'll show you right now.
Allie is going to give an example of this by pushing a car. Let's say that the car weighs 1,000 kilograms and that she pushes it 0.05 meters per every second. We can plug that into the equation F equals ma to get the net force.
Let go. Let go. Let go.
I'm going to drop the saltine box and the orange at the same time.
Presumably, you'd think that the saltine box would hit the ground first because it's heavier, but that is not true.
According to Newton's second law, the heavier object's acceleration decreases because it has more mass. So, both objects should hit the ground at the same time. Let's see if it's true. Ready? Whoa!
Hello there. Time to tell you about Newton's third law. Allie, what does Newton's third law say?
Every action has an equal and opposite reaction. When I throw this ball at the ground, it'll come back up with the same amount of force I threw it with. Ready?
For your second example of Newton's third law, I'm going to jump. The force that my legs apply to the ground is equal and opposite to the force that the ground applies to me. By this force being applied to me by the ground, I will be propelled into the air.
Jumpin', them boys up to something.
My last jump was not good enough, so I'm going to do it again.
Jumpin', them boys up to something. Jumpin', them boys up to something.
Thank you so much for embarking with us on this journey through Newton's laws.
I hope you really learned something and are more familiar with these laws. Today we're talking about Oh, I got. You know, my mom made that. My mom made that chair.
Okay, ready?
We'll drop it into the. Okay. I'll be the blonde bimbo.
Time to tell you about Newton's third law. Allie, what does Newton's third law say?
Alright.
Barbecue material. Hey! Time to tell you about Newton's third law.